Welcome to today's video. In today's video we're going to use SPSS to conduct a non-parametric Wilcoxon paired samples test. In a previous movie we looked at this problem and solved it using Excel. Remember that this was a study which was to determine whether there was a difference between husbands' and wives' attitudes towards online marketing advertisements. We had a questionnaire measuring this, was given to 24 couples with the results summarised in column C and column D. We have an ordinal range from 0, which 8, to 20, which means love. And what we wanted to do was, is there a significant difference with the couple's attitude to the online advertisements? And we chose a 5% level of significance. So we used Excel in that previous movie to solve this particular problem, to conduct a Wilcoxon signed rank test. So remember, the hypothesis test was no difference in attitudes to the online advert between women and men, or wives and husbands. The alternative was that a difference does exist, so there's the difference between the two medians. So we have a two-tailed test. Now remember, these are about populations, and we're using the sample data to try to say something about those population median values. So when we used Excel, we did a Z approximation, and we found that the calculated Z value was minus 2.3, and the two-tailed p-value was 0.02. And we compared that with a significance level of 0.05. Remember, this is a two-tailed test. The 0.02 is smaller than 0.05, so we rejected the null hypothesis and we accepted the alternative hypothesis. So based upon the sample data, the evidence suggested that there's a difference exists, a significant statistically significant difference exists between how wives and husbands rate particular advertisements, marketing advertisements. Now with Excel, it's quite a lengthy process, but with SPSS, it's a great deal easier. So let's go to SPSS. There's my data file. So I just want to show you how easy it actually is. So we click on Analyze, we click on Non-parametric tests, and now you can use the newer versions, i.e. related samples, but I'm going to use the legacy dialogues. And I want two related samples. Okay, so what I do now is I transfer women into variable 1 and the wives into variable 1 and the husbands into variable 2. We want a Wilcoxon test, and then once we've done that, we can then click on OK. After a few seconds, the results will appear. So what I'm going to just do is I'm just going to do a screenshot of those results. Okay, and I'm going to copy them across to Excel. Okay, so if I cut across now to Excel, to the actual numbers, and what I'll do is I'll just copy them into there because I want to just compare the results. Pardon me. So here we have the results here, and we can see that we have now this is swapped round so that we have the negative ranks. We have 7 now. We've swapped them around in terms of definition, because what they've done is they've done H minus W, husbands minus wives. We did it the other way around. Okay, so we did W minus H, so it's the other way around. So the signs and that just swap around. So we would have 7 positive ranks, which is equivalent to 7 negative ranks because of this husbands minus wives. Positive ranks is 15. There we are, 15. We have 24 in total. So we have 24 in total, as you can see there. And we have 2 tied ranks. And you can see that we have 2 tied ranks there. Okay. Now this is the statistic that we're interested in. So Z is minus 2.311. We had minus 2.3051. Now the difference for that is that SPSS will take into account any continuity correction for Z, but also it will correct the estimate of the population standard deviation due to tied ranks, which is what we haven't done. In the book, you'll see that there's some information about that, but they're comparable. So the two-tailed p-value is 0.021, and we had 0.021. Okay, so you get basically the same results. Okay, just a slight difference. Okay, so that's the end of today's movie. Bye for now.